explains the steps that we follow in order to draw the loose structure of some simple covalent compounds. I've written the steps here for you, and I will be following them to draw several examples. So first, I'm going to begin with CF4 molecule, carbon tetrafluoride. So the first step is to count the total valence electrons of the atom in the molecule and then divide it by 2 to get how many pairs you are going to distribute. Carbon belongs to group 14, so carbon has 4 valence electrons. And fluorine belongs to group 17, so it has 7 valence electrons. Now, since we have 4 fluorine in this formula, we are going to multiply the 7 by 4. So that's a total of 32, 28, 7 by 4 is 28 plus 4, 32 over 2. We have 16 pairs to distribute. The second step, we need to select the central atom and write the terminal atoms around it. Usually, the one in the center is the atom that has less electronegativity, or meaning maybe less valence electrons as well. So here's carbon. It's going to be placed in the middle, surrounded by F atoms. Now, F are called terminal atoms, and the one in the middle, I call it the central. And now I'm going to start distributing those 16 pairs. So the third step, you connect the central with its terminal atoms. 1, 2, 3, and 4. And then you complete the octet rule of terminal atoms, meaning here 5, 6, 7. This F completed the octet rule. 8, 9, 10. This one done. 11, 12, 13, 14, 15, and 16. So all these terminal atoms completed their octet rule. Now I would like to mention that if hydrogen is a terminal atom, it's the only one that cannot take lone pairs around it. And hydrogen atom can never be a central atom, meaning you will never see hydrogen connected to central and having lone pairs like that. This is wrong. Okay, so you can do this to all atoms but hydrogen. Now, after completing the octet rule of the terminal atoms and you're done with the pairs, if there are remaining pairs, you go back and you place them on the central atom. In this case, we finished our pairs by distributing them. So in the example CF4, step 5 is not applied. And step 6, we double check if the central atom completed the octet rule. Now C did complete the octet rule because C has now 2, 4, 6, and 8 electrons, and it is stable. Now let's take another example where step 5 is applicable. So NF3, nitrogen trifluoride. So nitrogen belongs to group 15, so it has 5 valence electrons, and fluorine to group 17. So 3 times 3, because we have 3 F atoms, divided by 2. So that makes it 26 over 2. We have 13 pairs to distribute. Again, I'm going to place N as a central atom surrounded with 3 F. So I have 13 pairs to distribute. So connect central with terminal. 1, 2, 3. Complete the octet rule of terminals. 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, what do I do with the 13th pair? Step 5 states that if there are any remaining pairs, place them on the central atom as lone pairs. So here, the 13th pair is going to be placed on N. And we double check, did the did all my terminals complete their octet rule? Yes. Did N complete the octet rule? Yes. N has 2, 4, 6, and 8 electrons, so N is stable. Now, let's take an example where step 6 is applicable. So let's begin with the example of CO2. So first, we count the valence electrons in the molecule. Carbon belongs to group 14. It has 4 valence electrons. And oxygen belongs to group 16. It has 6 valence electrons. And since we have 2 electrons, I am going to multiply it by 2 and divide by 2. So the total here, 12 and 4, 16 over 2, that's 8 pairs. So we place carbon as a central atom surrounded by oxygen to be terminal atoms. So the next step is to connect the central by terminal. The next step is to complete the octet rule of terminals. So far I've placed 1, 2, 3, 4, 5, 6, 7, 8. I'm done with my 8 pairs. However, the central atom carbon did not complete the octet rule. In this case, we start taking lone pairs from the terminal atoms and placing them as shared pairs between the central and the terminal. So what I'm going to do, this pair over here, I will take it from oxygen and put it as a common shared pair between carbon and oxygen. And I will do the same on this side. And like this, I created double bonds, multiple bonds. Here, carbon now completed the octet rule. The last example that I am going to explain is nitrogen. N has 5 valence electrons. So we have 5 pairs to distribute. N and N. I am going to consider this to be the central atom. So connect central with terminal. Complete the octet rule of terminal. If you have remaining pairs, place them back on the central. However, the central atom did not complete the octet rule. So we take from the terminal and we make them multiple bonds. So that's the first lone pair taken. And that's the second lone pair taken from this terminal atoms. Like this, the central now having triple bonds and completed the octet rule.